Our DLO for today is I will learn how to solve for a single variable in an equation. So go ahead and write that down. We're working out of your packet on pages 37 and 38, so you guys can go ahead and open up your packet to those two pages. There's only 3 types of examples that we're going to do today. We're going to do one type of each of them together, and then I'm going to expect you to do one of them on your own as well tonight for notes. And then tomorrow you guys can come back and do the other ones during class. So the first type of example we're looking at, here we have formulas, and it says formulas is the same thing as solving for x. The only difference is that nothing will add or simplify. So you're not going to be able to come out with a nice clean number. Your answer will not be like 4 or 3. Instead, it's going to be still a combination of variables and numbers. The only difference is that here we're solving for a specific variable, or we're trying to isolate a specific variable. So we're going to do this first one together where it says solve for r. This is on page 37. All right, we're going to do this one together. After that, I'm going to expect you guys to do this one on your own. All right, so in your notes, as soon as we're done with this first one, I'll pause. You guys can pause the video and do the second one on your own. Then these two, you guys can come back tomorrow and we'll do them in class. So for this first one, it says the formula, circle the variable. So I'm going to write down my formula. It says solve for r. Here's my formula. And the first step is to circle the variable. So I went ahead and I circled r because the directions say to solve for r. So I'm going to circle the r. Alright, so you guys can go ahead and write that on your papers as well. So circle the variable. The next step says add or subtract the terms that are not circled. Well, if you notice here, remember our definition of term. So a term is any combination of numbers and variables. So 2 pi r is actually all one term. Terms are separated, so if you have more than one term, they'll be separated by pluses and minus signs. If you don't have any pluses or minus signs on the same side as the variable you're looking at, then there are no separate terms. Which of these would have more than one term? Can you try to figure out which has more than one term? If you said this one, you'd be correct because here I see a plus sign. So these are 2 separate terms. So in this first step, you would be able to go ahead and add or subtract the terms not circled. So I just wrote the directions over here, add or subtract the terms not circled, but I crossed it out because there are no other terms not circled. So there's nothing to add or subtract. The next thing says multiply by any number in the denominator. Well, if I look up here again, a denominator implies that there's a fraction, so a top and a bottom of a fraction, but I don't see that in my problem. So again, there's nothing I can do for that step. I cannot multiply by the number in the denominator because there is no number in the denominator. Can you look again at these examples and try to figure out which one does have a number in the denominator? It would be the 4th one. Good, it has a 1/2. There's a fraction, so the 2 would be the number in the denominator that you could multiply. So again, I'll write it down, but there's nothing I can do, so I'm just going to cross it off right here again. Alright, for my next step, I can actually do stuff now, so let's go ahead and look at this one. It says, divide by anything next to the circled variable. So I wrote that right here, and actually it's in your packet as well, so let's look at it right here. Right here, it says, divide by anything that is next to the circled variable. So I'm going to rewrite my equation one more time so I can have it down here. And that's a easy way of saying it, divide by anything that is next to the circled variable. So if r is the circled variable, anything next to it would be the 2 and the pi. But there's actually a math vocabulary word for that I'd like you guys to use. It's called a coefficient. So I would say divide by the coefficient. You can always think of it as the number next to the circled variable or anything next to the circled variable, but it's called a coefficient. So on my left, notice here, by the way, the last step is to answer it. So on my left, nothing over here simplifies. Nothing is supposed to simplify. So it just stays c over 2 pi equals, on this side, the 2 and the pi both simplify to 1 because those are multiplicative inverses, and I'm left with r. Now let's see if we did exactly what they asked us to do. Up here at the top, they said solve for r. Well, we did. We solved for r. We got r all by itself. Another way of saying solve for r is saying isolate r, or get r by itself. And that's exactly what we did. So this is our answer. R equals c over 2 pi. So we did the first one together. We did the formula for circumference. This is the formula for circumference of a circle. I want you guys to go ahead and pause the video and do this one right now. So solve for t in this equation here. All right, when you guys are ready to move on, remember we're going to do these two tomorrow during class. All right, so let's move on to this next type of problem. The next type of problem says solving for y is just as easy. So again, we're doing the same thing where we're solving for y, but this time it's not necessarily a formula, it's just a random equation. The other ones up top were actually formulas for different things that you could calculate. So this one's just a random equation. 10x minus 5y equals 15. And we're going to solve for y. So I'm going to go ahead and copy my steps again. Circle the y term. There we go. I circled y. So I put over here circle y term. Let me write that word a little better so you guys can read that. There we go. Circle y term. All right, so we did that. The next one says add or subtract the x term. Now, this step, again, remember how up above we said there's like an easy way of writing it? This is an easy way of writing it. I actually like the way that we had it written up above, where it said that add or subtract. Remember this one right here? Add or subtract the terms that are not circled. So here we have negative 5y. This 10x is in a different term, right? Because it's separated, by a plus or minus sign. And so this is a separate term. So when I say add or subtract the x term, this one happens to have an x in it, but what if it was a different variable? What if it was like a w? So instead of saying add or subtract the x term, I want you to think of it like getting rid of the term that is not the one with the circled variable. So let's get rid of the 10x on this side. Again, this negative belongs with the 5y. This 10x has a little invisible positive in front of it. So we have plus 10x and minus 10x. I'm going to subtract 10x from this side. These are additive inverses, so I'm left with negative 5y equals, now look at this really quick because I think a lot of students might make a mistake on this. This is not going to equal 5x. Even though 15 minus 10 is 5 and we have an x right here, these are not like terms, so you are not allowed to combine these. So instead, I'm just going to write them next to each other. 10x plus 15. Remember at the very beginning I said that nothing's really going to simplify, nothing's really going to cancel out. You're not going to get a nice, even, pretty number. So we'll just keep it exactly like that, since it's not a like term. All right, the next step says divide by the coefficient of y. So I'm going to say divide by coefficient of y. So here's my coefficient of y, negative 5. So I'm going to divide the left-hand side by negative 5, and I'm going to divide every term on the right-hand side by negative 5. All right, you have to divide every term. So over here I have negative 5 and negative 5, all right, that equals y because those are multiplicative inverses. I have negative 10 divided by negative 5, that's positive 2 because a negative divided by negative is a positive, so that's 2x. And over here I have positive 15 divided by negative 5, so that's negative 3 because a positive divided by a negative is a negative. And that's my answer, y equals 2x minus 3. So my directions, again, were to solve for y or isolate y. So I got y all by itself, and I have everything else on the other side of the equation, so that's perfect. All right, at this time I want you guys in your notes to go ahead and solve this one. So we did this first one together. I want you to pause the video and solve this one right now. All right, when we're ready to move on, remember that we're going to do these two tomorrow during class, so don't worry about those right now. And let's look at page 38 for our last example. All right, so here's page 38. Let me write down example one more time. All right, so evaluating a formula given the values is just like evaluating an expression. So we're going to do a combination of what we've been doing already today in the notes, and then we're going to take it one step further. So it says in the formula D equals RT, I'm just going to write down the formula, I'm not going to write down all those words. In the formula D equals RT, it says solve for T. All right, and find the time it takes to travel 375 miles during driving at 75 miles per hour. So we're actually going to do that part in just a minute. I'm not going to write that down yet. So I'm going to go ahead and do this. It says identify the variables. Well, I have d, that's a distance. I have r, that's a rate, if you didn't know that. And I have t, that's a time. And so I'm solving for t, so I'm going to circle t, identify the variable. Alright, so I identified my variable. The next one says solve for the given variable. So just like in our steps up above, there are no other terms on the same side of the equation, so there's nothing for me to add or subtract, but I do have an r right here. So I'm going to rewrite one more time, d equals rt. I want to get rid of that r because I want to solve for t, or I want to get t all by itself. So I'm going to get rid of this r by dividing both sides by r. Those are multiplicative inverses, so they equal 1 when you divide them. So I get t equals d over r. So this is distance divided by rate equals time, and that is my equation solved for t. So I solved for my given variable. The next step says plug in the values of known variables and evaluate. So here's what that means. Any variables that my problem tells me, anything that I know, all right, I'm going to plug that in. So let me look back up here again. It says solve for t, we did that, and find the time. So when we're done, we're going to have a value for t. We're going to know what t equals. Find the time it takes to travel 375 miles. That's a distance. So I'm going to write distance equals 375 miles. All right. Driving at 75 miles per hour. That's a rate, or how fast I'm going. 75 miles per hour. So when I come back down here, it says plug in the values of known variables. So I'm going to plug in my distance of 375 miles. I'm going to plug in my rate of 75 miles per hour. And that equals a time. So last but not least, I need to simplify this and get my answer and be sure to include units. So I need to know how many times 75 goes into 375. So I encourage you guys not to use a calculator for this. I encourage you guys to do it by hand. So I'm going to figure out how many times 75 goes into 375. Well, 75 doesn't go into 37, so obviously I can't put anything into there. So I have to figure out how many times 75 goes into 375 altogether. So let's think about this for a minute. You can just start trying out different numbers, like for example 75 times 1 or 75 times 2, 75 times 3. And eventually you'll get to 75 times 5. And if you look at this, the 5 times 5 gives us 5, carry the 2, 7 times 5 is 35, plus 2 is 37. So 75 goes into 375 5 times. Alright, so we know that t equals 5. And it says be sure to include units. Well, remember that t is a time, and here my units are in miles per hour, so I know that my time is in hours. So it should say 5 hours, and I will box that up. So the time that it would take to drive 375 miles at 75 miles per hour is 5 hours. And that is it for our examples. I really quickly want you guys to go back, and I want you to do this one. Alright, so go ahead and do this one right now in your notes, the second one, and we're going to do this third one when you come back to class tomorrow. So make sure you pause the video right now and do this one in your notes. Alright, and we're all done for today, so go ahead and make sure that all of those examples are finished up, and we'll see you tomorrow.